going to be looking at thinking, and in particular discussing whether thinking is a skill. Is thinking something we can improve by attention, practice, by doing it, or is it just natural, like walking, breathing, talking, and we don't have to bother about it? Indeed, you could say, why do we need to bother about thinking at all? Couldn't we just stick to routines, habits, drift along, doing the obvious thing at any particular moment? But of course, there are times when thinking and being able to think has certain advantages, like in the following story. And it's set in the United States, and a young man goes to his bank manager and says, I want to open an account into which I'm going to deposit $1,000 a week. And the bank manager was delighted, as bank managers tend to be on those sort of occasions. So each week he personally turned up and deposited his $1,000. After a few weeks, one day he turned up and he was invited into the manager's inner office. And he went in, and there was the manager sitting at his desk. And with the manager was a strange gentleman who was introduced as being from the FBI. And they interrogated this young man. They said, where are you getting your money from? We know you don't work, you spend your time drinking, gambling, and we suspect you're getting your money by selling drugs. And he said, no, he said, I get my money from gambling. So they said, how can you be so sure of getting a regular income from something as chancy as gambling? He said, well, I only bet on certainties. So they laughed a bit and said, how you should be so lucky to find the certainties. He said, I don't find them, I make them. Anyway, they didn't believe him, and they were going to haul him in for interrogation. To save himself from this rather tricky position, he looked across at the manager and he said, I will make a bet with you for $1,000 that by this time next week your nose will be made of wood. So the manager said, don't be silly, you can't be serious. He said, oh, it's perfectly serious, regular bet, $1,000, this time next week your nose is made of wood. So the manager shrugged and said, okay, I accept your bet. The week passed, and the young fellow turned up, and this time he had a friend with him, and the manager said, nice of you to come and pay your bet. You owe me $1,000. As you can see, my nose is not made of wood. So the young man said, as may be, but I always check things out for myself. I never believe anyone's word for it. So the manager said, go ahead, check it out, feel my nose. So he leant across the table, grabbed the manager's nose, and gave it a very big, a very sharp, a very painful twist, a tweak. At this point, his friend collapsed, fainted on the floor. And the manager, noticing this, said, what's the matter with your mate, your pal there? He said, oh, him, he said. I made a bet with him for $2,000 that I'd walk into your office and grab you by the nose. So on that occasion, his thinking not only saved himself from a very difficult situation, but it also earned him $1,000 for that week's deposit in the bank. So there are times when thinking is of value. One of the other areas in which thinking has value is to enable us to do something much more simply. Now, supposing I asked you to add up all the numbers from 1 to 10. That's not a very difficult task, and by the time I finish speaking, some of you would have got the answer. Adding up all the numbers from 1 to 10. Any offers, numbers from 1 to 10? Anyone? Yes?
55.
55. Okay. Well, about 200 years ago in Germany, a teacher went into a classroom, and he sat down behind his desk, and he said to the youngsters, the young boys, I want you to add up all the numbers from 1 to 100. And the teacher sat back to read his book, which was the reason for giving them this problem. After about 10 seconds, this awful little boy put up his hand and he said, teacher, I have the answer, and the answer is 5050. The teacher was furious. He said, you couldn't possibly have worked it out in 10 seconds. Someone from last year's class must have told you, or your father, and so on. And the little boy said no. The little boy's name was Gauss, and he subsequently became a mathematical genius. And we use his name today in the unit of magnetism, and a magnetic field is a Gaussian field. And the boy said, no, he said, it's very obvious, he said. He said, here we are, he said, and if that's 1, and that's 2, and that's 3, he said, it's like a big triangle, and that's 1, and that's 100. And he said, if we split it in the middle, and we sort of hinge it, so this bit goes up there, then we get 101 times 50. 101 times 50 is 5050. Now, that's a particular way of looking at it. You could look at it another way. You could say, instead of adding 1 to 2 to 3, if we add 1 to 100, we get 101. If you add 2 to 99, you get 101. And when you come down and you run out of numbers, you get 49, you add to 52, you get 101. And then, of course, if you add 50 to 51, because these are coming down and these are going up, you get 101. So you get 50 times 101, 5050. In other words, our thinking here has provided us with a way of saving time, saving effort, and so on. So a particular use of thinking. Then there's another use of thinking, which is a very, very important one, and it's what Einstein used to call a thought experiment. And most of Einstein's work was actually based on just such thought experiments. Experiments he did in his mind, saying to himself, if I look at things this way or that way, what would follow? And then working out the results, and in fact getting an Italian to work out the mathematics for him. Now, we can do a thought experiment going back to the days of Galileo. One of the things for which Galileo got credit was showing that if you dropped a heavy object, the light object, they reach the ground at the same time, if they're so big that air resistance isn't a major factor. I say got credit for it, because in fact a Dutchman had shown it first, but Galileo had better public relations, so he got the credit. Now, we can do a thought experiment and show that that is very likely, even though all the philosophers of the day said it can't be. If something is heavier, it must get there faster, because that is what heaviness is all about, a sort of urge to hit the ground. So let's do a very simple thought experiment. And firstly, we choose the object. So the heavy object is 4 times as heavy as the light object. Then we change the substance of this, so it's the same substance as this. So obviously it's going to be much smaller. Next, we change the shape of that, so it consists of a cluster of 4 equal pieces. Then we change the shape of the cluster, and we string these out, so it's in a line. The weight hasn't changed at all, so on. Next, in our thought experiment, we separate these in our mind. Now, what has happened now is that these are equal, because that is divided into 4 equal parts. That is equal to these. So naturally, we would expect that since they're all equal, they're all going to behave in the same way, because they're all equal. Then we say, what happens if we now join them up? If we join these up, what would happen? Since they're falling together, the join could be a piece of chewing gum. It doesn't have to be a weld or anything. It could be a piece of chewing gum. If we join them up, for instance with a piece of chewing gum, what would we expect to happen? Would we expect them suddenly to accelerate because they're joined up? And if so, where would the extra energy come from? So which is the more surprising? And all science works on the balance of surprise. You can never actually prove anything. You can only prove things in mathematics, which is a closed system. But in science, you can simply say it would be very unlikely if this or that happened. So here we have the choice. Which is the more likely? That joining them up would make them accelerate, or that it would make no difference? The balance of surprise is it would make no difference, in which case, if those are equal, then joining them up makes no difference. That should be the same as that. Changing shape makes no difference as far as weight goes. Hold that. Changing shape again makes no difference. Changing substance makes no difference as far as weight goes. So as far as weight goes, it would be very likely that objects of different weight fell with the same acceleration. So by doing a thought experiment, we go through things in our mind, we think, in fact, in order to work things out. And of course, one of the main purposes of thinking is to go from things we know to things we don't know. And that's one of the important points of thinking.